We'll be investigating rational exponents and radicals. So we're asked, what is 5 squared to the 1/2 power? Using our rule of exponents, we know that we have a power squared raised to another power, so we can multiply. This would be 5 squared times 1/2. Well, 2 times 1/2 is 1, so this is 5 to the first power, or 5. Well, we also know that 5 squared is 25. So if we had 25 to the 1/2 power, how do we get that to equal what we know is true, 5? So the question is, what does the 1/2 power mean? Well, to go from 25 to get to 5, one way I could do this is by taking the square root of 25. And indeed, that is what a rational exponent is. A rational exponent follows these rules, where if I have a base b raised to an exponent 1 over n, or in our case we looked at 1/2, that is the nth power of b, or what we did the square root of b. I also have this second rule, where b, our base, is raised to a fraction, m over n, and I can rewrite this in 2 different ways. But we'll investigate that further. In simplifying 27 to the 1/3 power, I'm going to use rule number 1 to help me, where I have 1 over n, and n in this instance is 3. So I'm going to rewrite this as the cube root of my base, 27. And the cube root of 27 is 3. 3 times 3 times 3 is 27. I'm going to continue to use rule number 1 to look at this next example. 4x to the 8th raised to the 1/2 power can be rewritten as the square root of 4x to the 8th power. And so, in solving this, I know that the square root of 4 is 2, and the square root of x to the 8th is x to the 4th. And if you're unsure about that, let's take a pop out of what just x to the 8th to the square root, or we know the square root is also the 1/2 power. And here we can see that when we have a power raised to another power, we multiply. So 8 times 1/2 is 4, so x to the 4th is the square root, or 1/2 power, of x to the 8th. In this last example, 8 to the 2/3, I'm going to use my second rule. My second rule tells me I can rewrite this one of 2 ways. I usually prefer the first way to rewrite these, where I'll be taking a root and then raising it to a power. And so, 8 to the 2/3 tells me that I can take the nth root, and in this case, n is our denominator, so the cube root of 8. Then I'll be raising it to the m power, and m is our numerator in this instance, so the second power. The cube root of 8 is 2, so this tells me I'm taking 2 raised to the second power, which is 4. We can also simplify radicals by separating into this type of formula. If we have n to the nth root of a times b, that is the nth root of a times the nth root of b. Well, let's look at the square root of 45. The square root of 45 then can be rewritten as the square root of 9 times the square root of 5, 9 times 5 being 45. And the reason we broke it out to 9 times 5 is because we know the square root of 9 then is 3. Simplifying the square root of 45 then, we get 3 the square root of 5. So when simplifying radicals, we want to check to see if it's divisible by a perfect square, such as our examples were given here. Sometimes we'll be looking for a perfect cube, etc. So the square root of 24, I'm going to look to see what two numbers multiply to 24 and if any of those are divisible by a perfect square. If I'm unsure, I could take this square root of 24 and start by thinking about, well, what are all the numbers that multiply to 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. And again, I'm looking for perfect squares in this time since I'm taking a square root. And I see that 4 is a perfect square. So I'm going to rewrite the square root of 24 as the square root of 4 times the square root of 6, which then simplifies to the square root of 4 is 2, to the square root of 6. Simplifying these radicals then sometimes helps us in addition. Here I have the square root of 50 plus 6 times the square root of 18. So the square root of 50 I'm going to rewrite as the square root of 25 times the square root of 2, because I know 25 times 2 equals 50, and 25 is a perfect square, so the square root of 25 is 5 times the square root of 2. I'll now be adding to that 6 times the square root of 18. Again, I want to simplify this, so I have 6 times two numbers that multiply to 18. And one of them is a perfect square. Well, that would be 9 times 2. So I'm adding 6 times the square root of 9 is 3 times the square root of 2. And now we can see that 6 times the square root of times 3, the square root of 2, would be 6 times 3, or 18, the square root of 2. And if I have 5, the square root of 2's, plus 18, the square root of 2, 5 and 18 is 23 square roots of 2.